Hello guys, this is an implementation of an AI model called NeuroEvolution of Augmented Topologies, or NEAT for short. It is inspired by a real evolutionary process called natural selection, in which the best performing genes or species can pass on their genes and create mutations that can survive the next generation. For example, a giraffe population lives on a small island, and originally there were only one type of giraffes. But eventually, they reproduced and create a bunch of genetic mutations, and there are now two other types of giraffes, which are the tall-necked ones and the short-necked giraffes. And let's say all of these guys eat plants, which include grass and leaves and bushes and stuff. And one year there was a drought which killed all grasses and bushes, so the only source of food left on the island is the tree leaves. So the shorter necked giraffes cannot reach the leaves, and they have lower chance of surviving compared to the taller giraffes. And so the taller giraffes can reproduce more, and they can survive the drought and pass on their genes and create some more mutations, which diversity and therefore better chances of surviving. The same rules also apply with NEAT neural networks. How successful a genome is in its environment is measured by a fitness. For example, if the snake hits a wall or its own body, we can deduct its fitness by 100 or 200, and if the snake eats an apple, then we can reward it by giving it a fitness of plus 50. In this example, the first genome performs better than the second one, so NEAT will make a copy of it and change some of the weights and then configurations, and repeat this process until it reach a threshold, a fitness threshold, or we run out of generations. So the input layer is gonna take in data such as distance to the apple's position, and distance to the wall, and distance to the body, and stuff like that. And then we got the hidden layers, which have the network things, and the output layers, which can be 4 directions: up, down, left, right. So the plan is to call the train function, which is gonna run eval genomes function for 50 times, or the whatever number of generations you choose it to be. And this function is gonna take in the inputs, which we can call by get inputs function, and it's gonna run until it dies, or the number of steps is too big, and it's gonna get the fitness for this specific genome. And after all 50 generations are done, it's gonna get the winner with the highest fitness, and we're gonna save that to a pickle file, and then we can use the load run function to load the winner and run it. So first of all, I trained it for 500 generations to save the pickle file. So back then training, I actually forgot to turn on the analytics option, which is gonna save the fitness data into a list which we can visualize later. So I had to run it all again after that. So as you can see, the fitness started out at -1000 at first, which is pretty bad, and then it got up to around -900, plateaus a bit, and then -800, and then 700, 600, and it starts to get better and better. And after generation 200, which is around 1000 fitness, it doesn't really get improved much. the snake got a score of like 41 until it crashes into itself. I also made a file for you to play just a game by yourself using the arrow keys, and I started out at 20, but I got like pretty few points. So this time I actually want to visualize it while the model is training, so I changed the visualize model to true. Turning this option on would mean the model would run much slower. As you can see, it took like 30 seconds to run the first generation, and it's only gonna get worse from here. So the first few generations were pretty boring, and it just ran around in a loop until it discovers Apple, which it got a really big reward for, and so the model really starts getting better around generation 100. So I decided to only start visualization from generation like 120 or 130 because it took so much time.
Tired of intros.
And I ran it one last time to get the data for plotting. So as you can see, it got stuck around fitness of negative 950 and less than that until generation like 60, and then it got a massive boost to fitness, and then it starts getting pretty much better from there. Anyways, this project was pretty fun to make, and there were a lot of problems, but I overcame them. If you guys liked my videos, please like and subscribe. Thanks for watching. I'll see you in the next video.